Hello everyone and welcome back to my channel. In today's video, we're going to be looking at this very important thing in maths called logarithms. And this video is basically just a crash course in this topic, and it's going to give you questions, it's going to give you examples, it's going to give you a good explanation, and it's going to give you a very good basics of what logarithms are. So I'm aiming to not make this video too long so that you can refer to this video anytime you feel a bit unsure what logarithms are. So I hope you like this video. Grab a pen, grab a notebook so that you can follow along with me as I'm doing some of the questions. So let's get into this video. To start with, what are logarithms? Like, I'm assuming you haven't heard of this before, or if you have, this can serve as a revision. But let's just start from the basics. What are logarithms? So, the logarithm is the inverse of an exponent. Now, what is an exponent? You may know this, you may not. So, when you write something like 3, sorry, that's on rubber. When you write something like 3 square, that is you raising 3 to the exponent of 2. So over here, our 2 is the exponent and the 3 is the base. So the number which is being raised to a power is the base, and the power is our exponent. So let me just remind you how this works. If you've got 3 square, what this means is that you're multiplying 3 by itself 2 times. And if you've got something like 4 cubed, then you're multiplying 4 by itself 3 times. Why 3 times, you may ask? This is because the exponent is 3. Over here, we multiplied it twice because the exponent was 2. So I hope that was a good revision for you guys on what exponents are. Now, I need you to focus on these two words, these two terminologies, exponents and base. Okay, base is really important. Just remember, base is the number you are doing something on, right? So 3 is the number we're raising to the power of 2. We are multiplying 3 by itself twice. So the number which is like being kind of manipulated over here is 3, and that is our base. It's on the bottom, so it's the base. The exponent sounds a bit fancy, it's up there, that's why. So the exponent is the top number and the base is the bottom number. Cool. So let's look at some examples now. How does log really work? So, before I get into some examples, let me just write out how log looks like. So if you've got something like log A, B is equal to C, what does this mean? Over here, let me just break it down for you guys really quickly. A is our base. A is the base, okay? Over here, C is the exponent. See how this is a bit different to how you would normally write it. And this is our kind of like our product. This is the number that we get, the output / the output, you can say, when we do our function of exponents. Yeah? So what we can do over here, what does this really mean? So if we break it down from this explanation, we know that A raised to the power of C would equal B. Okay? So this is what this means. We know that A is the base, so we put the base down there. We know that C is the exponent, so we put it up there. And we know that B is kind of like our product / output, and that's why the answer is B. So now let's look at some examples over here. So log 5, log to the base 5. Let me just point this out. This is the base, this is the exponent. So log to the base 5, 25 is equal to 2. Why is this? Because when we put our base down here and we put our exponent on it, we get 25. Pretty simple, right? If you're not sure of it yet, don't worry, we've got 2 more examples. So if we've got something like log base 8, 64 is equal to 2, we know that what is the base over here? It's 8. So let's just write base over there. And we can't really squeeze in our exponent, so I'll just write e over here for 2. So that means that when we write it out, we would write it out as 8, which is our base, raised to the exponent of 2 is equal to 64 because 64 is our exponent. 64 is our kind of like our output. So that's why 8 squared is equal to 64 and log base 8, 64 is equal to 2. So you see how this is just a little bit of kind of like a puzzled way of saying the same thing, but log is a function that you can use on your calculator. So now we've got log 100 is equal to 2. Why is this? Okay, we don't have a specified base, as you can see. So what we say is that log without a specific base is log base 10. That's just a rule we need to know. So this becomes log base 10 100. Now we're thinking about what should I raise 10 to get 100. So we know that 10 to the power of 1 is 10. 10 to the power of 2 is equal to 10 times 10, is equal to 100. 100. And therefore, 2 is the exponent we're looking for, which is why we've got 2 over there. Does that kind of connect for you guys? So that's why 10 squared is equal to 100, and thus log 100 is equal to 2. So again, it's just a little bit puzzled way of saying the same thing. Now, something I need you guys to remember is why are logs important, really? Why do we need to learn about them? So let's say you've got a big question like, let's say you've got log base, I don't know, maybe 64 to a number like 2, 4, 5, 6, 7, 8. Okay, how would you do that? You have got no idea what power should I raise it to. Maybe this will give some number. You don't know, right? It's not that anybody would memorize this, right? So that's where we can use our calculators in order to use the log function on it and figure this out. Now, this may not be a perfect, like, 64 raised to a whole number may not give 2, 4, 5, 6, 7, 8. And that's okay, because our calculator can give you decimal numbers as well. Something like that. Yeah, I'm just making this up, by the way. I don't know if this is the right answer. So what this really means is that you can really use these functions in order to solve many equations. Okay, so this is really important, especially when you're going into advanced maths. You can manipulate expressions and equations very easily with logarithms, so it's very useful in that way. So let me just rub this out and let's go on to the next little bit. So let's just do some questions together really quickly. What is log base 3, 27? So we're looking for a number. So what number should I raise 3 by in order to get 27? Because this is our base, this is our output, and we're looking for our exponent. So let's go for 3 squared. We know that that is equal to 3 times 3, which is equal to 9. So what about 3 to the power of 3? That would be equal to 9 times 3, which is equal to 27. So that means that the number that we need to raise 3 by in order to get 27 is 3. Okay? Now we're looking for log 1000. Now, we don't have a specified base over here, so we're going to assume that the base is 10 because that's just the way it is. That's just a rule. And this can be written out like this. Okay? So now we're thinking of what number, since this is the base, this is our base, what number should I raise 10 by to get 1000? So there's this trick we know for base 10s. If we've got 100, 10 squared is equal to 100, right? So that's why 100 has 2 zeros. When we have 10 to the power of 3, our answer would have 3 zeros, okay? That's just a little trick. So that's why log base 10, 1000 is going to be also 3, because 10 raised to the power of 3 is 1000. Now the next thing is log base 264. How do we do this? Well, it's just, if you've played this game, which I have a lot in my childhood, which is 2048, it's a very cool, fun game, right? So we can go from powers of 2. It's basically powers of 2 in that game. So we've got 2 to the power of 1 is 2, 2 to the power of 2, 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, and 2 to the power of 6 is 64. So, what number do we need to raise 2 by to get 64? Of course, it is going to be 6, because look over here. Yeah? So, very, very fun once you get what logarithms are. So I hope you understood what we were talking about. Now let's move on to the next little bit. So this is called the natural log. This is the natural log function. So this a special number like pi in mathematics which exists. It is called the Euler's number, okay? And it is E. Sorry, it is E. E is the special number called the Euler's number, okay? So it was created by this famous mathematician, Euler, and he came up with this beautiful number, and it is used in many places in maths. It's a very useful number. You should definitely do a little bit of research on that number. I'm not going to go into what that number is all about, since that would make this video way too long. So this is your E. Now, what the value of this is 2.71828, so approximately, by the way, make sure you know that this is the approximate value. It's like how we write pi is equal to 3.14, but this is just the approximate value, yeah? Because pi has infinite number of digits, yeah? So that's the same with the Euler's number as well. So that's just E for you. So what is the natural log? Natural log is basically written as ln, because natural log, but it's just flipped around. So ln, what this really means is this is log to the base of E. And we've just got it a little bit fancier written because E is a very important number. It is used in many places in mathematics, so it's just easier to have a function for it. So this is kind of like how we had our log 100. So we had this base 10. We just said that it's base 10 even though there wasn't a base. So this is kind of like how E also gets a bit of special treatment like that. And that's why we get log base E can be written as ln. Okay, so if we had a question like ln E, what would that be? So log base E, that would be what number should I raise E by to get E? Now, as we know, something like 2 to the power of 1 is equal to 2, 3 to the power of 1 is equal to 3, so E to the power of 1 is also equal to E. Yeah, so that's why this would be 1. So pretty straightforward, just a bit of fancy treatment for this fancy little number, actually long number more like, but yeah. So that's E for you guys. Now let's quickly get into some logarithm rules. So we've just got a little bit more to go. We've got some questions that we're going to be introducing. So we're gonna carry on with log rules in my next video, which I'll link in the description box below, because it is getting quite a long of a video and I want you guys to have little chunks of video so that you can easily access what you want to look at. So in the next video, we're going to look into log rules, go into some examples, some questions, and then I'll just say thanks for watching, guys. I really hope you enjoyed this first part of this video. If you have any questions so far, drop them in the comment box below, and I will try to get to them as soon as possible. So thank you so much for watching. See you in the next part, which is linked in the description box below. Bye!